So now we will move on to expected value and variance of a discrete random variable. You can, variance you may be familiar from earlier in the syllabus of representation of data, but expected value, maybe that seems a bit unfamiliar, and it's essentially a mean. But how do we calculate expected value and the mean and the variance of a discrete distribution? Well, if we just take a simple one, there are formulas in your formula book, and literally whenever you get a question like this, you just need to apply those formulas. So EX, which is expected value, E stands for expectation, and the brackets means of, and then X means X, so expectation of X. And that's equal to the sum of, when you multiply the values it can take by the probability. And in a way, you could think, okay, if we did we'll just substitute, do it for now. So 0 times 0.1 plus 1 times 0.12 plus 2 times 0.36 plus 3 times 0.42. So that would get us to 2.1. And the reason why this works is, imagine we do this 100 times. And we would expect that for 10 times we get a score of 0. And then for 12 times we get 1, for 2 times we get 36, and for 3 times we get 42, right? That makes sense. So how would we do the mean for this? Well, you remember it's sum of xf over n. So if you did sum of xf over n, that would be 0 times 10 plus 1 times 12 plus 2 times 36 plus 3 times 42 over 100. And that also gets us 2.1. So hopefully you can see how that's like the mean. And so that should tell you that for the variance, we do something very similar to how we did variance in representation of data. We do sum of x squared p minus expected value, which is the mean, squared. So if we have a look here, we'd do 0 squared times 0.1 plus 1 squared times 0.12 plus 2 squared times 0.36 plus 3 squared times 0.42 minus 2.1 squared. And it gives us 0.93. And obviously if we wanted the standard deviation, we'd do the square root of that. As I said in the previous video, sometimes they might not give every probability, instead do like C or something, and you have to find that C first, or they may even give you, remove one of these and then tell you that expected value is 2.1, and then you have to work backwards to find that value of M or whatever. So that's all for this video. In the next video we'll actually move on to some patterns that you might come across in certain discrete random variables. And these build the concept of things like the binomial and geometric distribution.